Okay, this review is going through our tutoring from March 10th, 11th, or 12th, looking at balancing and classifying chemical reactions. So the first one's asking you to balance and classify the following. So let's classify it first. So remember that a synthesis is coming together. A plus B yields A, B for it. Decomposition is the opposite, the breaking up. So we have A, B yields A plus B. Our combustion is some hydrocarbon plus fuel, O2, always yields the same two products, CO2 plus water. Our single replacement, we have a single element breaking up a couple to be A now with C and B displaced. And then our double replacements in A plus AB plus CD, and our couple switches. So now A is with D, and we'll see C with B. So let's take a look at our first one for it. So we see PB as A, H is B, PO4 is C. Now notice that B is by itself and A is now with C. So this would be an example of a single replacement because we have one switch for it. So now let's balance it. We're going to have PB, we have H, and we're going to call it PO. We have PB, we have H, and we have PO. We'll see that we have one PB, 3 H's, and 4 PO's. We'll have 2 H's, 3 PB's, and then remember we're going to multiply, so 4 times 2 is 8. So let's start with our PB's first. So how do I make a 1 look like a 3? I'm going to put a 3 there. So I'm going to have 3 here. Then I have a 2 and a 3 situation. So the common multiple is 6. So I'll put a 2 here. It not only changes my H, but it changes my PO to 8. So then I need to find the H. I put a 3 here. That makes it 6. And notice that we're 3, 3, 6, 6, and 8. And now we are balanced for the single replacement. Now our next one, let's take a look. Na is A, Br is B, and we can notice that it breaks down into A plus B. So we would see that this is an example of a decomposition reaction. So we draw our line going down. We'll see that we have one Na and we have one Br. We have one Na and we have 2 BRs. So we're going to balance our Br first. When we put a 2 here, it not only changes Br to 2, it changes Na to 2 also. So our BRs are good to go, so we'll put a 2 up there, 2 and 2, we'll put a 1 there, and we are balanced for this decomposition. Okay, we have our hydrocarbon, it's some amount of C's per some amount of H's, we have our fuel, and then we have the same two products. So yes, this one would be a combustion problem. We draw our line going down. We have C, H, O, we have C, H, and O. We see C is 6, H is 12, O is 2. We see C is 1, H is 2, and then O is 2 plus 1 equals 3. Now when we're doing this, we want to make sure that we always start at the top. So let's do our C first. So how do we make a 1 look like a 6? We put a 6 there. So 6 times 1 gives us 6. And then it changes this O. 6 times 2 would now give us 12 plus 1 is 13. Now go to your H. How do you make a 2 look like a 12? Multiply by 6. So 6 times 2 is 12. Then we're going to see that it multiplies by the 1 of O. That's going to give us 6. Sorry, my glasses fell off. So then 12 plus 6 gives us 18. How do we make a 2 look like an 18? We multiply by 9. So we are all balanced for this combustion reaction. Okay, our next one. Mn is A, F2 is B, then it comes together as A, B for it. So this is a synthesis reaction because 2 becoming 1. So we draw our line going down. We have Mn equals 1, F equals 2, Mn equals 1, F equals 3. So we'll never make a 2 or a 3 look the same. So we'll put a 3 here, that makes it 6. We'll put a 2 here, it makes it 6, and it also changes Mn to 2. So our F's are good. So then we're going to put a 2 here, and then we have 2 and 6, and we're all balanced for this simple synthesis reaction. Okay, our last one. This one's a big one. We have Li is A, N is B, NH4 is C, NO3 is D. So now notice that A is with D, and C is with B. So this one would be a double replacement because we have 2 switches happening. So let's draw our line going down. So we have Li, N, NH, and NO. We have Li, N, NH, and NO. So we have 3, we have 1, we have 4, and 3. We have 1, we have 1, we have 4, and then times 3 is 12, and we have 3. So let's start at the top. How do I make a 3 and a 1? I'm going to put a 3 here. So that not only changes lithium to 3, changes NO to 9. Okay, then we have a 1 and 1, that's cool. Then we have a 4 and a 12. So how do we make a 4 look like a 12? We multiply it by 3. So 3 times 4 gives me 12, and then 3 times 3 gives me 9. And look at that. We're all balanced. We're going to put coefficient 1 and coefficient 1 for this double replacement. Thanks for watching.